Hi guys, good morning, good afternoon, good evening, depending on the time you are seeing this video. My name is Hussein Green, your favorite mathematics tutor. I'm so excited to have you this moment. God bless you. Okay, we have a problem here on the board. It says if y equals to x raised to power x raised to power 2, differentiate y with respect to x. One of my students in the university actually sent this to me. So let's see how we can solve this um, together. This is actually differentiation. This is found in calculus. Okay, so how do we solve this? We have solution y equals to x raised to power x raised to power 2. Okay, so how do we tackle this kind of problem? The first thing that we're going to do is to find the logarithm of both sides. So let's take the logarithms of both sides. Take logarithms of both sides. Take logarithm of both sides. So that will be log y base e equals to log x raised to power x raised to power 2 base e. Okay, log y base e is actually called natural logarithm. It can also be written as ln y. So if you have log y base e, it can be written as ln y. So we can write this as ln y equals to ln x raised to power x raised to power 2. Okay, so this can be written like this. It is still very, very correct. Okay, and you see that that ln y, the whole of this power of x can come to this side. So that will be x raised to power 2 ln x. Okay, so we can now go further to differentiate this. But before we differentiate this, let us see how we can recall some standard derivatives. Okay, so if you have, let's say recall, if you have a function of x, that is f of x being ln x, the f prime of x is going to be 1 over x. F prime of x means dy dx of dy dx. So dy dx of ln x is 1 over x. Also, if you have f of x being equals to uv, that is u and v are functions of x multiplying each other, what is going to be the derivative of this? The dy dx of this, or f prime of x, is going to be u dv dx plus v du dx. Okay, so if you have, this is called the product rule. If you have two functions of x multiplying each other, okay, the dy dx, or the derivative of that, is going to be we apply this formula u dv dx plus v du dx. So we are going to use these rules to differentiate this. Okay, we're going to use these rules to differentiate this. So how do we differentiate this? So if you have ln y equals to x squared ln x. Okay, ln y, if you are differentiating y with respect to x, you multiply it by dy dx. So ln y is going to be 1 over y dot dy dx equals to, assuming this is our u and this is our v, we're having two functions here. We're going to apply this product rule to differentiate this. So I'm going to keep, this is our u and this is our v. So I'm going to keep this x squared, then I'll differentiate ln x. If you differentiate ln x, that's going to be 1 over x plus, I'll keep v, that means I keep ln x, I differentiate x raised to power 2, so that is going to be 2x. All right, So if you differentiate this, this is what you are going to have. And you know that this can cancel this. You have x here left. Okay, so we solve further. So you have 1 over y dy dx equals to this place we are having x plus 2x ln x. So if you are having ln x times 2x, this is what you will have. You can still write the 2x here. Okay, all right, it's still the same thing. Plus 2x ln x. So if you are having ln x times 2x, this is what you will have. You can still write the 2x here. Okay, all right, it's still the same thing. So, and now we are going to make, we are looking for dy dx. That is the derivative of y with respect to x. So we are looking for dy dx. We are going to make dy dx the subject. So making dy dx the subject, that means y has to come to this side. But before we do that, let us factorize this. Because we are having x here, x is common, so we can factorize. So this is y dy dx equals to, what is common here is x, so we take x out. X divided by x will be 1 plus x here is going to be 2. So 2x ln x is divided by x is going to give you 2, going to give us 2 ln x. Okay, so we now make dy dx the subject. So making dy dx the subject, so y has to multiply this, so that will be equals to y times x into 1 plus 2 ln x. Okay, so dy dx equals to, you know that y is actually x raised to power x raised to power 2. So the whole of this is our y. So any place you see y, we can write this. Okay, so we substitute y with x raised to power x raised to power 2. So that will be x raised to power x raised to power 2 times x. This x is actually raised to power 1. So into 1 plus 2 ln x, we close the bracket. We can apply the law of indices here. So if you are having, x raised to power 2 times x raised to power 3, the answer is x raised to power 2 plus 3, and that will be x raised to power 5. Okay, so here we are having x raised to power x raised to power 2 times x raised to power 1. So we can add the powers. So if you add the powers, this is what you are going to have. This is what you are going to have. So you have dy dx be equals to x. We actually add the powers because the base is the same. So that will be x raised to power x raised to power 2 plus 1. So you have dy dx be equals to x. We actually add the powers because the base is the same. So that will be x raised to power x raised to power 2 plus 1 into 1 plus 2 ln x. And that is the answer. That is the answer. So if you are differentiating y equals to x raised to power x raised to power 2, so the dy dx or the derivative of this with respect to x is going to be this. Thank you so much. God bless you. See you in my next video. Bye.